Stop fantasizing about aliens visiting Earth. It is not that aliens do not exist, but that the universe is unimaginably vast. Even if alien technology far surpasses our own, they could spend their entire lives, spanning eons, and still never reach Earth. The scale of the universe has long since made any interstellar encounter impossible. It is not that aliens do not want to come, it is that they truly cannot. The universe as we perceive it, and the universe as it truly is, are two completely different concepts. In science fiction movies and novels, interstellar travel seems effortless. With a single jump, ships cross several star systems in days, easily shuttling between habitable planets. Aliens in flying saucers cross billions of light years to arrive on Earth with ease. These artistic embellishments have deceived us for far too long. The real universe is absurdly large, despairingly empty, and impossibly distant. Proxima Centauri, located 42 light-years away, is the closest, and I mean the absolute closest alien star system to Earth. There is no other. Even if aliens lived on a planet orbiting Proxima Centauri, if they piloted a ship at the speed of light, flying at full speed without rest, it would still take over 4 years to reach Earth. Many people think 4 years is a short time, something you can just grit your teeth and endure. But you must remember, Proxima Centauri is our nearest neighbor. In the vastness of the Milky Way, this distance is merely a fleeting brush. Our Milky Way galaxy has a diameter of 100,000 light-years, containing between 100 billion and 400 billion stars. Each star potentially hosts its own planets, countless worlds, seemingly bustling, yet profoundly empty. The average distance between stars is several, or even dozens of, light-years. It is like an endless desert, where 2 grains of sand are kilometers apart. Meeting is as difficult as ascending to heaven. Looking at the entire observable universe, with a diameter of 93 billion light-years, there are trillions of galaxies, with countless stars scattered within. The vast majority of interstellar space is absolute vacuum, darkness, and desolation between planets. What separates them is not just distance, but an unbridgeable chasm of space and time. The first constraint imposed by distance is an iron law of physics that cannot be broken: the light-speed barrier. According to Einstein's theory of relativity, the speed of light is the universal speed limit. Any object with mass, whether a spaceship, aircraft, or living being, can never reach the speed of light, let alone exceed it. Approaching the speed of light infinitely would require infinite energy, a cost no civilization could ever bear. Even if an alien civilization advanced to a Type 2 or Type 3 level, capable of building high-performance interstellar ships, their top speed would likely only reach 50 or 80% of the speed of light. The 4-year journey would double to 8 or 10 years. Just to reach our closest neighbor, it would take over a decade. What about those alien civilizations hundreds, thousands, or tens of thousands of light-years away, with flight times spanning hundreds of thousands or millions of years? No life form could endure such a long journey. This leads to the second fatal constraint, the limit of biological lifespan. The average human lifespan is only a few decades, even with future technological progress. Achieving cryonics or life extension, we might reach a few hundred or 1,000 years. On an interstellar scale, that is not even a blink of an eye. Suppose an alien civilization has an average lifespan of 1,000 years. If they wanted to travel 100 light-years to Earth, even if their ship reached the speed of light, it would take 100 years. Over such a long period, resource depletion, population growth, mental breakdown, and equipment degradation, any minor accident could lead to the total failure of an interstellar voyage. No civilization would exhaust the resources, lives, and cultural heritage of dozens of generations just to traverse the vast cosmos in search of a distant, unfamiliar planet. Seeking advantages and avoiding harm is the instinct of every civilization. An encounter with such an unbearable cost would be completely abandoned from the very start. Short-distance flights can be sustained by conventional energy sources, but for voyages spanning light-years or galaxies, the energy required is beyond our imagination. An interstellar spacecraft requires continuous power and life support systems, including oxygen recycling, food supply, and climate control. The resources consumed in a 100-year flight would be enough to sustain a civilization for thousands of years. No advanced civilization would waste such massive amounts of energy on a meaningless interstellar expedition. Many people might ask, couldn't we achieve space-time travel, wormhole jumps, or space folding? Admittedly, in theoretical science fiction, wormholes could instantly bridge billions of light years. But as of now, wormholes exist only in mathematical formulas and theoretical conjectures. To stably open a wormhole, maintain its passage, and ensure safe transit would require manipulating black holes, harnessing dark matter, and rewriting the laws of space. This would require at least a Type IV civilization or higher. Looking across the entire universe, civilizations capable of reaching such a level are few and far between. And there is another sobering truth. Even if the universe is teeming with alien life, the vast majority are low-level civilizations, trapped on their home planets just like humanity, confined within their own star systems, unable to break the bonds of their planets, and incapable of interstellar travel. We are all trapped in our respective cages, gazing at each other from afar, never to meet. This perfectly explains the famous Fermi Paradox. The universe is so vast, so where are the aliens? The answer is not the dark forest theory, nor is it that civilizations are hiding. It is the natural barrier of cosmic distance that keeps all civilizations completely isolated. You thrive and develop in your galaxy, while I live securely on my planet. We inhabit the same universe, yet we are forever separated by an unbridgeable distance. Never to meet in this lifetime, isolated for eternity. The cruel laws of the universe have long since determined the outcome. Our generation, the next, and even human civilization for the next few centuries, will never encounter real extraterrestrial life. Perhaps millions of light years away, there is a blue planet, inhabited by intelligent life just like us. They too are looking up at the starry sky, wondering about the edge of the universe, and questioning, in the vast galaxy, whether other civilizations exist. We may know of the possibility of each other's existence, but we will never have the chance to meet, communicate, or encounter one another. This is not a regret, but the balance of the universe. The immense distance prevents interstellar wars and avoids civilizational conflicts, allowing every civilization to develop steadily in its own home, without the invasion of alien civilizations or the crisis of interstellar plunder. Humanity can live and thrive safely on Earth, creating our own civilization. Looking at it from another perspective, we are actually quite lucky, precisely because the universe is vast enough and the distances are far enough. Those powerful, terrifying, and aggressive advanced civilizations have no way to cross billions of light years to reach Earth. We do not have to face alien invasions, nor do we face the threat of being crushed by a superior civilization. Being able to live in peace, experience the seasons, and embrace life is in itself the greatest kindness the universe has bestowed upon humanity. We don't need to obsess over what aliens look like. We don't need to fear alien invasions, and we don't need to fantasize about interstellar contact. Accepting humanity's solitude, accepting the emptiness of the universe, and cherishing our only blue planet to protect our earthly home is the most realistic and meaningful thing we can do. Thanks for watching. If you enjoyed this journey through science, don't forget to like, subscribe, and share this video. See you in the next exploration with Quantara Atlas.